This section is about trigonometric functions in right triangles. This is going to feel like a much more geometric chapter, at least in the beginning. And my goal for you today is to be able to use trigonometric functions. In class, I had students looking at these two triangles, and because they're similar, we can make a ratio out of the 8/6, and that it's equal to 4/3, because with similar triangles, what we know are their side lengths are proportional. And in class, I said, well, there are 6 total ratios that you can make out of these two triangles. And so if 8/6 equals 4/3 is one of them, another one would be 6/8 equals 3/4. We could also do 6/10 is equal to 3/5. And we could do the opposite of that. So 10/6 is equal to 5/3. And finally, we could do 8/10 is equal to 4/5. And if I flip that over, I'd have 10/8 is equal to 5/4. And these are the 6 ratios that we can make out of a right triangle. And it turns out these 6 ratios actually each has a name. Sine is the ratio of the opposite side length over the hypotenuse. And I want to point out that it matters where theta is. So theta is a Greek letter. We usually use Greek letters to stand for angles. So this is a different Greek letter. Here's alpha. If I label this angle alpha, for alpha, the opposite side is now the adjacent side. So the adjacent and opposite flip around depending on which angle you're looking at. But for theta, the opposite side is the one that's far away from theta. The hypotenuse is going to be the longest side of the triangle. It's also the length that is opposite the right angle. And the adjacent side is going to form the angle theta with the hypotenuse. So sine is the opposite divided by the hypotenuse, and the mnemonic device that I still use, even though I'm quite old, is SOHCAHTOA. So stands for sine is the opposite over hypotenuse. Cosine stands for cosine is the adjacent over the hypotenuse. And tangent, TOA stands for tangent is the opposite over the adjacent. So that's how I remember which one is which. And then the 3 new functions, which you might not have learned about last year, are cosecant, which is sine flipped over, and secant, which is cosine flipped over, and cotangent, which is tangent flipped over. So this example is, I've labeled my angle theta. My angle theta is up here, and I need to find the trig ratios for that angle. First of all, the 29 is the hypotenuse. I know that because it's opposite the right angle. I also know that because it's the largest side length. And if theta is right here, then the 21 is the opposite side because that is farthest away from theta. And the 20 forms the angle theta with the 29. So the 20 is the adjacent leg. So sine would be so opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. And cosecant is going to be sine flipped over. It's the reciprocal of sine, so 29/21. Secant is the reciprocal of cosine, so 29/20. And cotangent is the reciprocal of tangent, so 20/21. This one is one for you to try. If you pause here and try it and then restart after you've done the problem, you should be able to check your answers. Okay, these are the answers that I got. Notice that the 12 is opposite theta because it's the farthest away from theta. 37 is the hypotenuse because it's the longest side of the triangle. It's also opposite the right angle. And then 35 is adjacent. Also, I want to be really clear that I wasn't misspeaking. Sine and cosecant really do go together, and secant and cosine really do go together. It feels like they're kind of misnamed, but that's how it is. And then tangent and cotangent, it makes more sense that they're the reciprocals of each other. Right? It turns out that you can also find all of the trig ratios if I just give you one of the trig ratios. This triangle is not on your note sheet. I would recommend that you draw a right triangle if you are trying to solve one of these problems. And so I drew a right triangle, and then I decided I'm going to call that theta. You can decide where you want to put theta on your right triangle. And so if that's theta, then because I know tangent, I know that the opposite side should be 15. And the adjacent side, that's not the hypotenuse, the one that forms that angle but isn't the hypotenuse, is going to be 8. And what I notice is that I can now fill in tangent and cotangent, but I can't get the rest of them unless I know the hypotenuse. So the tool that I'm going to use to find the hypotenuse is the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared is equal to c squared. Make sure that when you use this theorem, you're always putting the hypotenuse with the c. It doesn't matter which one is a and b, but oops, I spelled hypotenuse crazy. But it does matter that the hypotenuse is c. So then if I do a squared plus b squared, that would be 8 squared plus 15 squared is c squared. And it is okay to grab a calculator if you need to. And this would be 289, which I definitely need a calculator because I'm going to take the square root of that. Normally, I would have two solutions because it equals c, sorry. Normally, I would have two solutions because it's a quadratic, but because it's a side length, I just need the positive solution. So that means that c is 17. And once I know that, I can fill in all of the rest of the ratios. Sine is opposite over hypotenuse. Cosecant is that flipped over. And cosine is adjacent over hypotenuse. And secant is that flipped over. This is one for you to try, so I recommend that you pause the video and then restart it after you've given this one a shot. So pause now. Problem, we were missing one of the legs. We knew the hypotenuse, so when we did a squared plus b squared equals c squared, we had to do a little bit more algebra to figure out that a was 7. Once we knew that, we could do our ratios. All right, the last type of problem you'll see is finding a side length in a right triangle using these trig ratios. I mean, it's really cool that we can write these trig ratios, but it doesn't really mean anything unless we can use it to solve a problem. So here's our problem. A fire truck has an 84-foot ladder extended against a building forming a 55-degree angle with the top of the truck. The truck is 8 feet tall. The firefighters are trying to reach a window that is 75 feet above the ground. Will they be able to reach the window using the ladder set at this angle? So I'd recommend that you try drawing a picture before you attempt this problem. Absolutely, you need a picture, but also try drawing a picture before you look at mine. I'm going to show you what the textbook drew for a picture here. Okay, so this is the picture that I have. The ladder is 84 feet, so this side length should be 84 feet. We're going to pretend this ladder extends all the way out. The angle with the truck is 55 degrees. And we are trying to find this missing length of the triangle so we can tell whether it reaches 75 feet. I want to point out that they said that the truck is 8 feet tall. The truck is outside of the right triangle, which means we don't need our ladder to reach up 75 feet. We only need our ladder to reach up 75 minus 8 feet. So we need our triangle to make sure it can go to 67 feet. Okay. So what we're going to do is we're going to look at this. I care about the opposite side, and I have the hypotenuse. So if I think in my head about the trig ratios, the one that doesn't use adjacent, or the one that does use opposite and hypotenuse, is so, because that doesn't have any adjacent in it. So I'm going to use sine of 55 degrees. And just to really emphasize, after the word sine, cosine, or tangent, the next thing should be an angle. 55 degrees is the angle. And then we're going to do opposite over hypotenuse. Now, if I want to solve for x, I'm going to have to multiply both sides of this equation by 84. So I'm getting the x by itself. When I multiply this side times 84, the 84's cancel, and I need to multiply this side times 84 as well. So I have 84 times sine of 55 degrees. So then I'm going to have you grab your calculator. You're going to grab your 84 calculator, and you're going to go to mode to make sure that your calculator is in degrees. You want to make sure that the word degree is highlighted. If it's not highlighted, like if the radian is highlighted, you're going to arrow over until degree is highlighted, and then you're going to hit enter. And then to get out of this mode window, you can hit second quit, which is on top of the mode. And then I'm going to do sine of 55 degrees times 84. And I get 68.8. So 68.8 feet is how long this length is. I needed it to be at least 67 feet. So yes, it's tall enough I can reach the window. Okay, here's another example. The sun is shining at a 60-degree angle to the ground. How long is the shadow cast by a 20-foot tall flagpole? So I'm going to draw a flagpole here. Here's my flagpole, and it's 20 feet tall. It has a shadow. I don't know how long that is. And then I have the sun up here, and it makes a 60-degree angle with the ground. And now I have a right triangle, and I care about the piece on the ground, and I care about the opposite. So I care about the opposite and the adjacent, which means I'm going to use tangent. The next thing is an angle. So tangent of 60 degrees equals 20 over x. Now, if I want to solve for x, unfortunately, x is on the bottom, so I can fix that by multiplying both sides of everything by x. And then I want to solve for x, so I need to get rid of this tangent of 60, so I'm going to divide both sides of the equation by tangent of 60. And then I'm going to grab my calculator and figure out what that is. So it's 20 divided by tangent of 60. And that looks like it's 11.5. So the shadow is 11.5 feet. All right, I hope this helps. After today, you should be able to write the trig ratios in a right triangle, and you should be able to use trig ratios to solve for a missing side length in a right triangle. Thank you so much. Bye.